One last video on the topic of electropneumatics here. We have so far, wait, my learning music is not, why is our learning music not? There it is. So far we have an electropneumatic control when I press the start button that somehow the sequence up here works and our solenoids are activated in the solid three-way sequence here, which works so far, but that's good. But for whatever reason, let's not consider why. We want to add, was that always here? That's stupid. We want to make this, we want to split this up even more. What we have so far is the pneumatic circuit up here, and for simplification reasons and for putting them closer on the screen, I will get rid of the flow control valves, so I have more space on one screen, so it's easier to observe what's going on. That's the only reason why I take those out, just so we can observe better. That more fits on one window. We will split this up to three parts. We have our input part here, right? With all our sensors, we won't change that because that's done once. That's good. We have our output part. This here, right? This will be in the end. This will be our output part, right? And in between those two, right? Let me put a. Can I still do that in this version? I hope so. Miscellaneous bitmap. No. There's a comment. I could always put a comment on there. Can I not put a comment on there anymore? Graph set? No. Music board? No. Digital technology? No. Miscellaneous. Should be on the miscellaneous. Okay, it doesn't matter. Doesn't matter. Let's consider this is our input part. This is our output part. And our output logic will change. So this will change. And this will change. And we will have different components here. Steps. Step 1, do this. Step 2, do this. Step 3, do this. Step 4, do this. So I can already consider this. What should happen to make this simple? I will have my switches. I will still have my make switches here. And let's see what should happen in the following sequence. This is what should happen. In step number 1, this one should extend. So this will be step number 1, right? And I want to display the name here. Step number 1, I want this one to extend, which is 2 and 1. So in step number 1, 2 and 1 should activate, right? That's good. Then I want this one to extend, right? This one extends next. So I will need step 2, right? Step 2 should extend that one. That's already the correct place. That's good. There we go. In step 3, this one will retract. So I will need this one here in step 3. This one will retract, and in step 4, this one will retract. Now I've got a slight problem. I cannot have this one here in step 4. In the contrary, actually, I need this one here active in step 1, 2, and 3. And that's what I wanted. Should extend in 1, 2, and 3. So I can simply say this should be active in step 1, in step 2, and in step 3. Should have copied the other ones, but that's okay. Right. This is when this one should extend. That's as simple as it is. That's really the simple idea here. That's this. Here we go. No magic involved at all. So this one will extend in step 2 and step 3 as well. So let's see if that works already. No, doesn't work already. For the simple reason, what is step 2? What is step 3? What is step 1? What is step 2? And so on. So we need something called a step definition. What we have is an input side, an output side, and we need the step definition, the program, if you could call it, the program in between. For the program, it will be a relay control program. We will need a lot of those things here, so-called relays. And this is just a relay coil. This usually goes together with those contacts, right? So we will, whoopsie daisy there. we will need for each step one of those. So I will also give them the names. Step 1, whoops, step 1, step 2, step 3, step 4. And it automatically does that actually. We don't. Yeah, in step 4, this one should retract, right? So we had 1, 2, 3 where it extends, and in step 3 and step 4 it retracts. So we need those. Of course, we will also need a power source for them. This is our step logic here. 1, 2, 3, 4. They will all, as always, need the negative connection here as a 0 reference. They all need that. Electricity and so on. I have no idea how electricity works, but it certainly needs a neutral point so that the current can flow. We need a current loop, always. A closed loop for current to flow. I know that much. Electrical engineer here. Yes. Now we need to consider when is step 1 active, when is step 2 active, when is step 3, and when is step 4 active. Right? Well, when are all these active? Step 1 is active. Let's think about it. Step 1 is active when, right now, this needs to be the state, and I press start. Right? So now I need to evaluate what should be active. K1, well, we want this retracted. K3, this is retracted to B1, and the start button is pressed. So I will need K1, K3, K5. And they're all normally open contacts. K1, K3, K5. K3, K5. Short explanation to the music that's running. I download everything copyright free from YouTube that I could find that had somehow concentration or so in a sense, no, inspiring in its name. So that's why the music's playing it. So let's see, if I press play now, you can see K1 and K3 are already active. Those are our 2 sensors here. That's good. And what's missing is K5. As soon as I activate K5 here, you can see the second cylinder will toggle on and off, right? Because you can see it here, K5 is closed, but K3 opens and closes all the time. Now, this is a slight problem because we don't want that. What we want is this one should latch itself, right? It should activate, the step should activate, and it should stay in that step. And that's why for every step, we will also ask, is the step active at that time? Right? Is step 1 active, then please stay activated. Is step 1 active, then please stay activated, and this will prevent us from doing that over and over again. Right now we're in step 1 and we stay in step 1. That's very good. The problem right now is how do we get out of step 1? A simple solution here. We take a...
Class, this particular procedure is called latching. Okay, so when you will learn ladder logic also, you will have something like this. Okay, so just for your understanding, you can just have a look that how we latch a particular operation. Okay, so for example, if we just initiate, there is just a push button, so it will give a 24-volt supply only for a simple incident, or it will give you an instantaneous supply and then it will switch off automatically. So we do latching operation so that to continuously get an output from that. Okay.
Brake switch here. We take a brake switch and we just put in the next step in there, step 2, so that whenever we enter step 2, we will break this loop here. Right? Whenever we enter step 2 now, this will be broken and we will only be in step 2. So we will need this logic, this latch for all of our steps actually. Right here. Right? This needs then to be step number 2. Needs to keep itself active and can be broken by step number 3. Step number 3 keeps itself active and can be broken by step number 4. Step number 4 keeps itself active and can be broken by step number. What's the next? The next step would be step number 1, because we have a sequence going over and over again. Here we go. So let me just push that up here. Doesn't matter where it is. So we have those, right? What we now need is the condition. When should step 2 activate? If we think about it, step 2 should activate when we are in step 1, right? That's an activation, right? This is an activation for step number 2. And also, let's look at this. Step 1, 2b2 gets active. So for the second step, 2b2, K4 is also conditioned. So give me one of those. Let's call it K4. And this will be our condition for step number 2.
Excuse me.
Right here, right now, like this. Right. Let's see. Step number 1, click, and step number 2 right after. Those are right now pretty fast because I haven't slowed them down with flow control valves. Maybe I'll do that, but in a minute. What we need now, same thing for step number 3. Here we go. Push those one lower so they're all on one level. It needs to look perfect. Doesn't need to look perfect, that's just me right now. So to activate step number 3, we need to come from step number 2. And let's check this. 1b2 needs to be active. 1b2 is K2. Right? This needs to be K2. As simple as it goes. You go there, you go there, you go here. Same, you guessed it, same for step. Something's not right. I don't like that. Here we go. Same for the next, right? To go into step 4, step 3 needs to be active. And let's check this. And I want this one activated here. That's what I want. This was my sequence that I wanted. K1 needs to be active. Here we go. I click on this, and K1 is just a representation of the sensor automatically closed here. I actually turned off that feature for the other versions I have of this software. So what we have now, if I press play, if I press the start button, you can see this switching over just nicely there. 1, 2, 3, 4, 1, 2, 3, 4. If I go to the single step here, I activated the start. Now K5 will activate. K5 will close this. That's the first thing that will happen. K5 here is closed. Activating step 1, right? Step 1 here will keep itself closed, right? Even if K3 here is already open, which is a sensor, step 1 keeps itself active. Step 1 up here closes and activates 2M1. 2M1 is active, activating the cylinder here, extending. That's good. Next thing that will happen, 2B2 will come active, right? 2B2 will come active. 2B2 is connected to K4. K4 will close, activating step 2. Step 2 will close this one here, will keep 2M1 active, will close this one here, will activate 2M1. So let's see. 1M1 active, 2M1 also active. There we go. 1M1 is active, meaning cylinder 1 should extend here. There we go. Should start extending. In the next step, that's how it's called. In the next simulation step, 1B2 will get active, right? 1B2 is connected to K2. K2, step 3 will activate. Step 3 will activate here. Step 2 won't be active anymore. Step 3 will activate, deactivating 1M1, activating 1M2. So let's see. Step 3. Now we can see it. We'll go back. The cylinder will go back. And as soon as we reach 1v1 here, K1 will close, step 4 will activate, step 4 is active. We'll deactivate step 3, right? Step 3, only step 4. Everything here is deactivated. This has a return spring and will return back. There we go. Good. That's good. That's pretty much what I want, right? That's pretty much what I want. We could add one more. What we want to do now is I want 2 and 1 to activate, right? I want first the cylinder 2. Wait, what was our sequence now? I forgot it. Yes. In step 1, this cylinder should extend. Then, not having the sensor anymore here, right? Not having the sensor anymore, 2v2 is gone, meaning 2v2 here is gone. K4 is gone, right? We have to replace the sensor by something, right? And this something I want to be a time delay. I want this to be a time delay, and we have so-called relays with a switch on delay. This nice little guy here. There's also switch off delay, but let's only look at the switch on delay here. This one behaves the same way as those. It has contacts that we can activate, deactivate, open, close, but with a time delay. So it will activate 1, 2, 3, 4, 5, and then the contact will close, not immediately. So if I put that in here, in parallel to my step 1, why did that happen? In parallel to my step 1, somehow. And I will call that something like T-on. T-on means timer on delay, that's the name. T-on step 1. That's what I would call this one here. Quite a long name, so yeah, let's put that somewhere where it looks nice. It's okay. And this I want now here, instead of my sensor, because the sensor is gone. This here, and I will call this all, so I will give this. You can see the symbol changed. This symbol is now indicating that it's a delayed contact. And I can also set the delay time. Delay time is 5 seconds. 5 seconds is okay. So now I activate. I press the start button. Sensor is active. Timer is running here. 2, 3, 4, 5. Contact closed for a very short amount of time. You can see that. Timer closed. And sequence runs. Right? That's an on delay. That's nice. That's a nice thing that we have there. So to round this up, we have our pneumatic circuit here. We have our inputs. Right? With our inputs, we have our outputs right here. Let me somehow move you. Thank you very much. Our inputs, we have our outputs, and we have our program logic down here. So that's quite a lot. But that's why you have a video. You can watch that over and over again. Let me just push that a little bit so it fits all on one screen so I can make it.
So class, you have seen this video. I have a few questions for you. Was this video associated with the pneumatics more or the association of pneumatics with the process? Was it completely related to mechanical engineering? Yes or no? Class, kindly respond to the question. Was it completely associated to mechanical engineering? No. So now you believe that pneumatics is associated to every kind of engineering, and every kind of engineering is associated to pneumatics. Now, my question to you is that what were the things that you have extracted from this? First of all, for any process, is there a sequence that has to be followed in a particular process? Yes or no? Is there a sequence that has to be followed? So apart from having a detailed detailed knowledge about a particular process, one more thing that is required is that you should know the sequence. Okay, so and one of the most important thing for a particular process to be operated is a sequence. Okay, and my question, next question is that a sequence a sequence is integrated through sensors and actuators by a particular logic. Yes or no? Let me repeat the question. Yeah, Bhanu says yes. Okay. Okay. So my next question to you is that can we make a logic by using a for a particular sequence by using pneumatics? Can we make it? Is it possible to make a logic through pneumatics? Is it recommended to use pneumatics as a logic station? No, no. Okay. So we can use instead of pneumatic logic, what we can use? We can use a PLC or electrical logic associated to it. Okay. So PLC will have a logic inside it. Okay. We will integrate it with we can have an electronic logic also through relays that we have also seen in the previous video. But we should have a particular step sequence. Okay, so the sequential working of a particular, what we say, a sequential mapping of a particular process is very much important. Okay, we have seen that how much important it is that we should learn a particular sequential flow of a particular process, that how a sequence work. Okay, so we will dig deeper and deeper into a particular process, in any particular process, that how we can extract excuse me, extract a particular sequence of a particular process. And so my next question to you is that can this is associated to the question that Shubham asked. Can we directly give a command through a sensor to an actuator? Can we directly give a command from a sensor to an actuator? No. 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 So if process is not complex, okay, if process is not complex, yes, we can, but power is a issue, Bhanu, yes or no? Is power a issue, that the kind of power that we get from a particular sensor is not? Yeah, yeah, this is an issue also. So we need to have a particular sequence, we need to have a particular process, we need to have sensors, we need to have actuators, we need to have an sequential, you can say, algorithm that is associated. So for any simple process, it is very important for us to understand a particular sequence. Okay, am I correct or not? Yeah. So I think yeah, yeah. So I think this is enough for today, or shall we proceed with a little bit more, or we should conclude for today, or we should end the session for today? It is up to you. I can continue for more 15 minutes. Enough? Okay. 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 So for the today's conclusion, what we have learned is we have learned about pneumatics, how pneumatics is associated to your electronics, and how we link pneumatics to a particular electrical or electronic control system. Okay, so and we have also learned about it, how steps are important. Okay, so there are steps in a particular process. We need to understand the step, we need to understand the sequence, and how that particular sequence work for a particular process, and then we should proceed, because things will be easy then. Okay, so with that I conclude today's session. We'll meet tomorrow.